We're actually going to be doing expected payout, and that's fun. But we got to start with the shortest PowerPoint on record, which is this one, Law of Large Numbers. But before we do, I just want you to know that calculating expected payout has a lot to do with games of chance, among other things. So if you think about going to a casino or someplace where you gamble, you have to ask yourself, are these people really on my side? In other words, are the odds with me or are they stacked against me? And I think any reasonable person would just decide, hey, it's stacked against you, because if they just gave money away or gave prizes away, they would soon be out of business. So what they do is they work it so that you win, and you can even win big, but in the long run, they win more often than you do. So that's the idea behind the law of averages. In other words, casinos know what the math is. So when they put up a game out there, or roulette wheel or whatever, they know you can win, and you have to win occasionally so that you can keep coming back. If you never won, you'd never go. Or if there was no way you could win, you just wouldn't bother. So it's a fine line that they work, but it is decidedly in their favor. So let's just start out, law of large numbers. We've done this before. It's just saying that the long run relative frequency, let's just say long run probability of repeated independent events, eventually settles down to the true probability as the number of trials increase. So if I flip a coin 10 times, I might get 8 heads, and that's a proportion of 0.8. You would expect 0.5, but I just haven't flipped them long enough for it to settle into that 0.5 that we all know and love. So the long run is a really long time. It just is enough time to give the trial probability enough time to even out to the true probability. Okay? So that's a very long-term kind of phenomena, and we will clarify our expected payouts as being what we would expect to get in the long run, which means this, a long, long time. All right, as far as short term goes, remember we talked about law of averages. If you're a 70% free throw shooter, then somebody used the law of large numbers to figure that out. They just watched you shoot a whole lot of free throws, and so you settled in at 70%. But if you miss 5 in a row, you can't just say, yeah, the next one's a surefire hit, because really you don't know. It's 70% yes and 30% no, just like the previous 5. So no law of averages. If you hear anybody using it, they're messing up. All right, so this is, you can do law of large numbers with probabilities, means, anything that's a repeating phenomena. And you can see a lot of variability at the start, and then as you get further and further along, things tend to lay down on their actual true value. So we can witness this. And here's a demo. Get this going. All right, so this is flipping heads. Probability is 0.5. We can put up a line to show that. And we're just going to start out with 15 tosses, and they're all over the place. Okay, some above the line, some below the line, but they're not really hugging the line. So let's make this a little more definite and move this to 200 tosses. All right, we're above, but we're sinking down, 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 down. A little variability, because 215 tosses is hardly infinite, but we'll do 200 more. And you see how we're really kind of hitting that 0.5 mark? There's some variability still, but as you average these tosses and get a more and more accurate proportion, you should nail that true value of 0.5. So that's all I wanted to show you here. All right, now if you were not here, I did make up a sheet of expected value and expected payout, and you don't have to do number 10 because that's one that was on Thursday night's homework, so just cross that out. but this is replacing what's on the calendar. There's just something not quite flowing well in this chapter, so I'm trying to make some adjustments on the fly, and well, this should be a better assignment than the one you had, at least as far as you learning something. Okay, so we're going to go to page 9 in your packet, and in the meantime, I am going to pause. All right, so we're back, and these are working with games of chance, and so here we go. So you're invited to play a game of chance. I'm on number 1. You draw a card from a standard deck of 52 cards, you know, the usual. If you get a red card, you win nothing. All right, so we're going to start with getting this thing. Let's see if I can get the point right. Okay, we're going to go ahead and start with a probability distribution. All right, and we're going to have start out with a straight line, ended up with a crooked line. Let's try something like that. All right, so X is going to be our expected payout, and we'll have an associated probability to go along with it. So if you get a red card, you win nothing. So that's a 0 for an expected payout. Half of your deck is red cards, so that's 26 out of 52. You don't have to reduce it if you don't want to. If you get a spade, which is 1/4 of your deck, you win $5. All right, so there's a $5 win. That didn't look good. Let me get that a little better. And that's going to be 13 out of 52. So that's 1/4. And the last event is kind of a dual event. You can win $10, or you can win 10 plus an extra 20, which would make 30. And let's see. The 20 extra to make 30 will be 1 card. That's your ace of clubs. So that is 1 out of 52. That leaves you with 12 of the 13 clubs remaining to win $10. So 12 out of 52. Okay, so there it is. Your probabilities all have to add up to 1, which that should. And then it says find the expected amount you'll win. All right, so that's just finding the mu of x, say, or the mean of your random variable. But I'm going to use e of x. Remember I said that was another option? This really lends itself to this kind of problem. So we're just going to find the mean, and most of the time you're finding the mean. Occasionally you'll find the standard deviation with it, but this will be 0 times 26 out of 52, which really isn't going to contribute anything since you're multiplying by 0. And then 5, and that probability is 13 out of 52, plus 10 times 12 out of 52, plus 30 times 1 out of 52. All right, so it's not uncommon for them to throw in a great big win, this 30, but at a very small probability. Okay, so if you do the math and run this through your calculator, your expected win per game in the long run is $4.13. Now keep in mind, you had to pay $5 to play the game. So you play that consistently, and in the long run, you're supposed to only win $4.13 back. That is an 87-cent deficit. So let's write that out here. So in the long run, you expect to lose 87 cents for every $5 you pay to play. So for each $5 you pay to play. All right, that's not good. But keep in mind, it's just like as in a casino, it's not unusual for you to play games that are stacked against you. And think about it, if you're paying $5, you could either break even or double it, or get it up to a factor of 6 if you get extremely lucky. So, you can answer this. This is actually an opinion question. For me, I might play this game. I mean, if you think about it, 87 cents, that's actually less than 20% of what you pay to play, right? So, yeah, what I might do is I might play this game for possible short-term gains. And if I don't realize any short-term gains, then I may just bail after paying $5 3 or 4 times. If nothing comes of it, I might just move on to something else. Okay? All right, so there's that one. Here's another game to consider. Now, this first game, you paid the $5 up here up front to play. In a wager game, you're not paying up front. What you're doing is you're going to play the game, and whoever wins gets the $5, and whoever loses loses the $5. So it's money exchanging hands, right, after the game is over. So I roll a pair of fair dice. If I roll doubles, 2 dice are equal, you win the game. Otherwise, I win the game, okay? So let's go ahead and do this. All right, we'll set up our distribution here. And there's really, here's X and P of X. There's really only 2 things that can happen. You can win $5, so that would be plus 5. You could lose $5, that would be minus 5. All right, if you're going to win by rolling doubles, so that's 2 1s or 2 2s, 3s, 4, 5. That's 6 out of 36 ways that can happen. That leaves 30 out of 36 for it to not happen. All right, so you win for this probability, you lose with this. Now, it's pretty clear that this one's stacked against you. So let's figure out the expected payout for this. So that'll be 5 times 6 out of 36, or 1/6 if you will, plus a negative 5 times 30 out of 36. Okay? And when you're all said and done, that will give you 3.33, wait for it, in the negative. All right? So it's not comparing it to what you paid in, it's just what is going to end up in your pocket for each game in the long run. And that's a deficit. So you're paying somebody else to play this game. Not so great, and it's a lot of money based on a $5 wager. So might not play this game. Yeah, that has too much going against you. So we can make the game a little bit more interesting. Okay, can't wait for that. Again, I will roll the pair of dice. If I get doubles, you win. If I get a sum of 9, then I win. All right, the I's and U's get a little confusing here, but let me just guide you. It's basically the same thing as what we saw previously. All right, so again, we're going to start out with X and P of X. And you can either win $5 or you can lose $5. But if you don't get the doubles or the sum of 9, then you just roll again. So that means no money exchanges hands. That's a 0. Okay? So this will still be 6 out of 36. But now, how many ways can you get a 9? Well, there's a 5 and a 4, 4 and a 5, 6 and a 3, 3 and a 6. That is 4 out of 36. Now compare that to 30 out of 36. Now things got better. So that's 10 out of 36, leaving 26 out of 36 for just spinning your wheels, no money changing hands. So the expected outcome for this, expected payout, is 5 times 6 out of 36 again, plus a negative 5, but this time it's times 4 out of 36, plus 0, which isn't going to add anything, but we'll keep it there, 26 out of 36, and that'll give you an expected payout of 28 cents. So it's pretty close to breaking even, which is far better than it was up here, right? So let's write this one out. So you expect to win 28 cents every time you play in the long run. Right? So you're either going to win $5 or lose $5. So you're not going to get that in an individual game. But the average for a long, long time playing this is 28 cents in your favor. Right? I would play this one. Right? That's pretty close to 50-50 winning or losing. All right? And maybe you'll get lucky. Okay? All right. So now we've got another one, and I'm just going to change colors here. This one costs $8 to play. All right, so you're going to kind of commit to that. You're going to throw 3 dice. I pay you $5 for each dice that shows a 6. All right, so here we go. And let's see what we've got here. So x and p of x. Make that a little longer. All right. So if no 6s show up, you're not going to win anything. So that'll be 0. And we'll do the probabilities in a moment. You could get a 6, right? So that would be 1 6, or that would give you $5, right? You could have 2 6s, which would give you 10. You could have 3 6s, which would give you 15. All right. Now, it's going to be a little weird to get these probabilities, but not impossible. All right, I'm not listing, well, let's see, it's 6 times 6 times 6. That's 216 outcomes. I am not listing those. So let's just say 0, you get 0 6s, okay? That's going to be not a 6, which would be 5 out of 6, times not a 6 again, that would be 5 out of 6, times another not a 6, that would be times 5 over 6. That would be 125 out of 216. All right? Now to get 1, this is going to be the tricky one. Okay? You could get a 6 on the first one, that would be 1 6 times 5 over 6 times 5 over 6. Or, that would be plus, you could get your 6 on the second one. So that would be 5 over 6 times 1 over 6 times 5 over 6. Or, sorry about the cracking voice, you could get the 1/6 or the 6 on the third die roll. So that would be 5 over 6 times 5 over 6 times 1 over 6. Well, each one of these is 25 over 216. So there's 3 of them. That will be 75 over 216. See, not too bad. Then you could do 2 6s. Well, that would be 1 6 times 1 6 times 5 over 6. That's one way it could happen. Or is plus. You could have the first and the last. So that'd be 1 6 times 5 over 6 times 1 over 6. Or they could be the last 2. So you could have not a 6 times a 6, that's 1 over 6, and another 6, right? So those are all going to be 5 over 216, and again, there's 3 of these, so that'll be 15 over 216. See? Not so bad. And the third thing can only happen if you get 3 6s and win $15. That can only happen one way. That would be a 6 and a 6 and a 6. That would be 1 over 216. Okay, so that is everything. Yeah, so let's do the expected payout, because that's basically what they're asking. What's the expected payout of this game? Which we can also compare to what we paid in to see if it was worth playing. So this one, 0 times 125 over 216 plus 5 times 75 over 216 plus 10 times what, 15 over 216 plus 15 times 1 over 216. All right? And that will give you, I believe, $2.50. So $2.50. All right, that answers the question. But it doesn't really tell you much about whether it's worth playing. You paid $8, you only get $2.50 back in the long run. So you basically, you lose $5.50 each time you play in the long run. And remember, we always have to kind of preface, not preface it, but end this with in the long run. Because these aren't short-term outcomes. All right? So yeah, this is nope. Yeah, I don't want to play this one. Looked good, had some potential, but yeah, I think not. So time to do my brief pause, so stand by. All right, so here is the last thing we need to cover today. It's another game of chance that we're going to get an expected value for. So you roll a die. If it comes up with a 6, you win $100. Okay, that looks like a good start. So let's start with that. Okay, and you know, X, P of X, usual stuff. And so there's a winning, $100, and it's if you roll a 6 on a die. That's 1 out of 6, all right? And if you don't get the 6, you roll again. And if you get a 6 the second time, you can win $50, all right? That's a funny looking 50. Let's make it a little not so funny. Not much better, but it'll work. All right, and if you don't get a 6 that second time, then you lose, okay? It's these two probabilities that we need. So I'm going to resort to a tree, and these are independent events. So here's your first roll, and we'll split off like so. This is a win, and the probability is 1 over 6. And this is a loss, or you lose. That's 5 over 6. And so if you come up, if you come up that direction, that's it, game over, you win your 100. And you can, I guess, play again, but you're just going to start from scratch. If you lose, however, you get another roll. And again, two things can happen on that. Let's just put a line here. And so this would be a win, which would be 1 over 6, or lose, which would be 5 over 6. And so there's two things that can follow. You can lose and win, which is 5 over 6 times 1 over 6. Remember, they're independent. So that's 5 over 36. Or you can lose and lose. So that's 5 over 6 times 5 over 6. That's 25 over 36. And if you convert this to 6 over 36, it adds up to 1. So let's find the expected amount we'll win. So E of X equals 100 times 1 over 6 plus 50 times 5 over 36 plus 0. And I know this, we could probably leave this out, but it just makes things complete. All right, and this will give you a fairly good payout. It's like $23.61. So that's $23.61. Not bad. We don't, however, know what the cost to play. And it's implied that there is one, because what would you be willing to pay to play this game? All right. Well, this is more of an opinion question, just like the first one that we did. $23.61 is pretty good. And most people would say, if it's less than that, I'll play it. But What if it costs $25 to play? Would you do it? Because that's only like $1 and some change above the expected payout, and you could win 100 or 50, right? Because that would be 6 over 36 and 5 over, that's 11 over 36. It's almost a third of the time you would win one of those two numbers. But it's, what most kids said was, I would play if it costs less than $23.61 to play. And that's okay. Be conservative. In fact, don't gamble at all, because it's always stacked against you. It can make an addiction, and you can lose a lot of money and ruin your home life. And what would be the point? But I have to say, I did once gamble. I was on a trip to Alaska, which in of itself was wonderful. And my aged father was up doing what he wanted to do more than anything, which was sit on deck, smoke cigars, and eat ice cream. And that's what he did. And I thought, no, that's not for me. So I went exploring on the ship. It was a little after lunchtime, and I found their casino. I didn't even know they had one. And it was deserted. And I thought, this is the perfect opportunity for me to go ahead and, scratch off one of the things on my bucket list. So I got $20, got some tokens, went over to the slot machines, the one-armed bandits, and started to play. And I was ready to lose all $20. So played one, nothing, played another, nothing, no matches, played another, maybe a couple more, and then I put in one, and all of a sudden the lights went off and sirens went off, and these tokens just poured out of this machine. Okay, now I wasn't knee deep or hip deep or ankle deep. I got about $50, and I thought, sweet, this is great. This is all I ever want to do. I mean, the happy brain chemicals just flooded my brain, and I was hooked. So I said, I could do this all the time. I don't need to work anymore. So I started feeding those tokens back in, and I suddenly realized in pretty short order that it was cleaning my clock, right? Now I was still ahead, but I said, all right, this is what I'm going to do. I can't even believe I fell for this. I'm a stats teacher. I should know better. So I set a limit. If I get down to $25 in tokens, I'm out. I'm going to quit while I'm ahead. And sure enough, I never won again. It hooked me. It wanted all my money. And if I had not had a little bit of a positive frame of mind with the whole thing, I could have lost everything, which was not a huge amount of money in the first place. But you can extend that to grander sums, and things could go horribly wrong for people. So anyway, so just remember, gambling is fun, but set some rules for yourself when you get old enough to do it, if you're going to do it, and don't be silly about it. But anyway.